You ever wonder what really happens when you click on something online? I mean, it feels totally instant, right? But in that tiny fraction of a second, your request kicks off this absolutely incredible journey, all the way across the globe and back. So today, we're going to break down that trip from your keyboard to some server thousands of miles away. It's pretty wild when you think about it. A single click can send information literally circling the planet in the blink of an eye. So how on earth is that even possible? What are the invisible rules and highways that make our whole digital world work? Okay, let's dive in. And this is exactly why this stuff matters so much. As this quote from our source material puts it, and I think this is brilliant, networking isn't just a piece of the puzzle. It's the entire board. Every single decision an engineer makes about building an app or a website, it all rests on the foundation of how this global network operates. All right, so before our data can go anywhere, it needs to get packed up and addressed correctly. This first part is all about prep work, getting your request ready for what's going to be a long and pretty complicated trip across the internet. Think of it exactly like sending a package through the mail. Your simple request, like, hey, show me this web page, gets wrapped up in a bunch of different layers. The application layer writes the message. The protocol layer puts it in a standard format, like HTTP. Then the transport layer adds the delivery instructions. The IP layer slaps on that final destination address. And then finally, the physical layer turns the whole thing into tiny pulses of light or electricity to shoot through the wires. Now, this is where one of the first big choices happens. Which delivery service are we going to use? You've got TCP, which is like sending certified mail. It's a bit slower, but it double checks to make sure every single piece arrives, and in the right order. This is absolutely critical for things like payments or APIs, where you can't lose a single bit of data. On the other hand, you have UDP. Think of this like a postcard. It's super fast, but hey, a piece might get lost along the way. Perfect for video streaming, where it's way better to miss a single frame than to have the whole video pause and buffer. Okay, so our little data packet is packed and addressed. Now it's time to leave the cozy confines of your home Wi-Fi and venture out into the vast, kind of chaotic, digital ocean of the public internet. So the very first thing your packet needs is a real, machine-friendly address. We type in easy names like google.com, but computers don't get that. They speak in numbers, an IP address. The domain name system, DNS, is basically the internet's giant address book. Its one critical job is to look up the name you typed and translate it into the right IP address so all the routers know exactly where to send your data. With that IP address locked in, the journey really begins. And your data packet doesn't just travel in a straight line. Nope. It hops from router to router to router. Each router acts like a traffic cop. It looks at the final destination address and says, okay, the next best stop is over there, and sends it on its way. It's this massive, real-time game of connect the dots happening constantly to find the fastest path. So our request made it all the way to the server. Great. But now comes the really hard part, sending all that content, all the images, the text, the video, all the way back to you, and doing it fast. This is where the real performance challenge kicks in. And here's the core issue. If a server is sitting in California, trying to send a high-def video to someone in Tokyo is going to be slow. That sheer physical distance creates a delay, what we call latency. A single server, no matter how beefy it is, just can't give a fast, smooth experience to everyone on the planet at the same time. And that brings us to the really clever solution, the Content Delivery Network, or CDN. So instead of one server in California, a CDN puts copies of the content on thousands of servers all over the globe. That way, when you request that video in Tokyo, you don't get it from California. You get it from a local server maybe just a few miles away. This slashes the travel time and makes everything feel almost instantaneous. But even with a CDN in place, you still have choices to make. If you're streaming a movie, you'll probably use something called HTTP-. It's smart. It breaks the video into small chunks and can actually switch to a lower quality on the fly if your internet connection gets a little shaky. That's what stops that dreaded buffering wheel. But for a live video call, you need real-time speed. That's where WebRTC shines. It creates a direct, super low latency connection between you and the person you're talking to. But even with the right protocol, you can still hit traffic jams. A classic problem is called head-of-line blocking. Just imagine a single-lane road. If one car breaks down, nobody behind it can move, right? The exact same thing can happen on a network. If one data packet gets lost or delayed, it can hold up all the perfectly good packets waiting behind it. And actually, modern protocols like HTTP3 were designed specifically to fix this exact problem. So when you start to put all these different pieces and protocols together, you see the bigger picture. And if there's one single thing to take away from all of this, it's that networking is a constant balancing act. Every single decision you make is a trade-off. This table just sums it up perfectly. You want absolute reliability? You use TCP, but you give up a little bit of speed. You need raw, blazing speed? You go with UDP, but you sacrifice that guarantee of delivery. Want a simple, universal way for apps to talk? REST is great for that, but you might end up fetching more data than you need. You see the pattern here? There is no single best protocol. It's always about picking the right tool for the job you're trying to do. So we've unpacked the whole journey, we've navigated the protocols, and we've weighed all the trade-offs. You know, the absolute best way to make all this knowledge really stick is to apply it. So it's time for you to become the architect. The source material gives us a pretty clear mission. Try this out. Grab a piece of paper or open up a whiteboard tool and actually draw the entire journey we just talked about. Label all the layers, the protocols, the routing stops. Then, think about a specific app and decide which API style would be best. And finally, just sketch out a basic plan for how you'd use a CDN to deliver video. This is how you really, truly master these fundamentals. Because at the end of the day, the internet isn't some fixed, magical thing. It's a living system that's built on millions of these small, deliberate choices made by engineers every single day. Understanding these choices gives you the power not just to use the internet, but to build on it. So the final question is, what will you choose to build?